Hi guys, welcome back to your new lesson. This is Lakshmikant Tiwari. So let me show you the first of all the final result of this lesson. In the final result of this lessons, we will be predicting a sentiment of a sentence. For example, let's say if I say, wow, this is amazing lesson, and if I run this, it says that 1. That means this is a positive sentence. I mean positive sentiment in this the sentence. But if I say, wow, this sucks, now if I run this, you will see here a 0 result. That means this is a negative sentiment. But if I say here clf.predict worth of watching it, please like it, it says that the 1. In meantime, I can test one more. Let's say the y.predict. Just I say loved it. Amazing. Now you see here, this is the 1. Okay, perfect. So this is how this is the result which we will be getting in this lesson. But let's go ahead and start from here. So the first I'll explain you what is the NLP and how we can do the text data cleaning with the SpaCy and skiller, and then what is the bag of word and then TF-ID. Then we will start this step by step and line by line coding, and then I'll show you how stop words and these things are, how you can do the lemmatization part of speech and the syntactic dependency, entity detections, etc. And then we can start text classification on these data set, Amazon, IMDB and ELP leveled review data system. Alright, after that I'll be doing a lot of the data exploratory analysis, then I'll do the tokenizations, then the text data cleanings, then finally vectorizations of feature engineering, then finally I'll be doing testing and the training and testing of the model, and then finally this is what I had shown you earlier in starting of this lesson. Alright, if you have not watched my previous videos, you can go ahead and watch those videos at my channel KGP Talkie. Alright, so the KGP Talkie, I have made so many videos on the NLP and TensorFlow 2.0 and classical machine learning, and on the Python, normal Python lessons, and apart from that the feature selections, then the random forest decision tree and all those things. There are so many lessons in this lesson. You can watch these lessons and you can download the working files from the video descriptions and you can test those by yourself. Alright, so without wasting time, let's go ahead and start this brand new lesson. Alright, let's go ahead and get started with NLP tutorial 8, Amazon and IMDB review sentiment classification using SpaCy. The first question comes in your mind, what is NLP? But before that, I should tell you, if you do not know anything about the NLP, I would recommend you to go ahead and watch basics of NLP lessons at my channel KGP Talkie. There I had started NLP tutorial 1 to NLP tutorial 7, and this will be the NLP tutorial number 8. Alright, so in these tutorials I have talked about the basics of NLP. So this would be a little bit advanced, but I will be covering all the things together in this lesson although. So the natural language processing is the field of artificial intelligence concerned with the processing and the understanding of a human language. The computer only understands the numeric values or numeric data, but the computer do not understand the humans. So in the NLP, what we do, we convert the text data or voice data into a numerical form, and then we train our models and make the computer learn that model or that data and perform accordingly as we instruct a computer. Alright. So there are many applications of the NLP like text classification, which we are going to do in this lesson, spam filtering, voice text messaging, sentiment analysis, spell or a grammar check like Grammarly. You might have heard about a product Grammarly, and chatbot. Now almost every companies are using the first line of the customer support as a chatbot. Then search suggestions, automatic search suggestions, automatic search corrections, automatic review analysis system which can find out the negative and the positive review and let the customer care take action accordingly. and then the machine translation like a Google translation, and so much more. Alright, so there are a lot of the application of natural language processing or NLP. Around the 50% of the data are into a text form, and the text data are mostly the unstructured data. That is why it is a little difficult to work with the natural language processing. So if you do not have necessary libraries, you need to install those libraries like pip install scikit-learn. If you are using Anaconda, so scikit-learn comes automatically, and then you need a SpaCy, pip install SpaCy, and then you need a Python SpaCy download English version of the library or a package SpaCy, and then here you can also download Python SpaCy download encore WebSM. That's mean a small model. There are three type of model available in SpaCy. Small model, which is the basic model which we can use in this lesson, that would not affect the performance. There is another model, medium and the large model. We use medium and the large model when we use a word to vector model. In this lesson we are going to use bag of words model, but in coming lessons we will be using vector word to vector models, where we will be needing a larger data set, which we can say encore wave MD, that is the medium, or encore wave LG, that is for large. All right, so how we will be cleaning our text data? There are so many things which we can do in SpaCy, like a case normalization. We can make a capital, or we can make everything in a lower case. We can remove a stop words. Stop words means a frequently occurring words like and, hence, so, that, okay, hey, hi, hello. So these are the the stop words which occurs most of the time. And then the removing punctuations are as special symbols. Okay, so these also comes very frequently, and does not include much information in the text classification. Then we can do the lemmatization or stemming. Lemmatization or stemming means the converting the text into its root form, or stripping a text into a shorter form. All right, so like let's say if we have a two word, continuously and the continuous. All right, so continuously and the continuous, from continuously ly will be the cut down, and continuously will become a continuous only, because these two words are conveying same information. And if we strip down the few the few characters and just convert few characters in last, that is known as a stemming. But if we convert if we bring down any word to its root form, that is the lemmatization, and that root form is known as a lemma. For example, let's say you have run, runs, and running. So the run, runs, running have a root form of run. All right, then we have here part of speech tagging. In a part of speech tagging, we can understand that what is the part of his speech of each word, and then with the entity detections and dependency, syntactic dependency analysis, we can find out how the words are correlated to each other. And then with the entity detection, we can understand, is there any organization, geographic locations, or the person, etc. are mentioned in a text. And then finally we will be using bag of words and TF-IDF formula to do text classification, that is the Amazon's and IMDB review sentiment classification. So let's go ahead and understand what is a bag of words. This is the simplest word embedding techniques. You can say this is the simplest word embedding techniques. Although this is not very much used in an industry, but as a learner, as a beginner, you should learn what is a bag of words, and you should be able to make a model and train your model and test your data at least with a bag of word. At least you should have that capability. And how it works, bag of words, I have already explained in my previous videos, but in this I'm also going to explain it very shortly. Let's say you have these three docs, doc 1, doc 2, and the doc 3. In this bag of words, what it does, it make a column of unique words, and then it counts in each doc how many times that word has occurred. All right, So in the, let's say, how many unique words are there? I am high, and then I am high. All right, so I am high, this is there. So S is only being added from doc 2, and then I am is already present in doc 1 and doc 2, then the kidding is only being added. So these are the just 5 words are unique. And then we make a frequency total, how many times these words occur in each of the document. So this is how a bag of word works. And how this bag of words and TF IDF work together. If you see here, if any words occurring most of the time, then the frequency will be the high, and in that case that will contribute more. And if we use a straight bag of word, then that is the disadvantage. Because let's say if something is happening very often, or some word is happening very often, that doesn't mean that convey some information. All right, for example, the many people mention all right, okay, so these people mention many times these words, but it doesn't mean that these words are giving any much information regarding what we are talking about. So that is why TF-IDF is introduced. That means a term frequency times inverse document frequency. That's when there is term frequency. That's mean how many times a particular word has occurred in particular documents, and then multiplied by inverse document frequency. That's mean how many times it has occurred in whole document. All right, I mean in all the documents. So if you see the overall, the formula is kind of this. Okay, so this is the very simple formula. Let's say you have n number of documents, then you can calculate a TF-IDF by using this formula. Log 1 plus total number of documents in your the data set divided by 1 plus how many times has occurred a particular word in a particular documents. I mean for that word in that documents, that would be the TF-IDF value and plus 1. All right, so this is the TF-IDF. All right, so how the NLP work, I mean how SpaCy work. So the TF-IDF, we will be using this from the scikit-learn library, but we will be also using the NLP module of SpaCy for cleaning of our dataset. As we mentioned here that we need to clean our dataset, like case normalization, removing of stop words and the punctuations, lemmatizations, all those things we will be doing in this lesson. And for that we need SpaCy. And the SpaCy NLP module in SpaCy is having this kind of a pipelining. If we pass any text to the NLP module, then it first tokenizes that text. A tokenization means breaking a text into a part. The first it breaks a text with a space, and then it breaks text with if there is any punctuation like comma, the question mark, exclamation mark, or a period, etc. And after tokenization, a tokenization is always a first step. Then after tokenization, we have tagging, parsing, NER, and sentence segmentation, etc., etc. There are so much things. Okay, all those things I have already covered in previous video, like here, and here. So in these, I have covered these things in very details. You can disable few modules, you can enable few modules, you can change these pipelining sequence, etc. You can go ahead and watch those here in my previous videos. All right, so let's go ahead and get started with this lesson. So the first of all, we need to import a SpaCy. By assuming that you have already installed the SpaCy, you can import a SpaCy. One more thing, once you install the SpaCy from the Jupyter command window or any the command window, then what you need to do first, go ahead in the kernel and then restart and the clear output. So in this way, what it will make the Jupyter notebook will make sure that you will get the libraries which you installed, packages which you installed, get linked with this new Jupyter notebook. Otherwise, that might create a problem to you. All right, so let's go ahead and get started with this. The first of all, you need to import a SpaCy, and then you need to import a matcher. I don't think we need a matcher, and neither we need a span. So you need to import a SpaCy, and then you need to import DisplayCy. We will be using DisplayCy to visualize our data, our text data. Let's go ahead and run this. So once we run this, it might take a little time the first time whenever you run it. Then we are going to load a small version of English library, English package from SpaCy that you can load with NLP is equal to SpaCy dot load and then en underscore core, and then here we have underscore wave underscore sm. All right, so this en says that load a English language library, and this sm says that load a small model. So there are multiple models. Go ahead in previous videos and see those models. Okay, so here NLP is loaded. Now let's go ahead a text which you want to first tokenize. So I'll take each steps first. I'll tell you each of these steps first, then I'll explain. Then I'll take you how you can classify text using these the NLP modules and scikit-learn TF-IDF the package. All right, so we are going to first do a tokenization. So this is first sentence and this is another one. Here third one is. All right, so you have, let's say, this type of the text. So what we are going to do, we are just going to call here doc equal to the NLP and then text. All right, so if you see here a doc, you will not notice any changes here, but now the doc is containing a lot of the information like tokenizations, parsing, part of speech, etc. So doc is containing all those information, but if you just print the doc, it will show you a same text which was earlier. All right, so let's go ahead and print the tokens. How we can get those tokens? We can just type here for token in doc. All right, print token. All right, so if you see here, this is the token which has been printed out. All right, so this token has been printed out. Now let's go ahead and break it into the sentences. How you can break it in sentences? Let's say we have a sent is equal to NLP dot create underscore pipe. Now you see there is no sententizer here. So this is how where we can add a sentence segmentation after named entity recognition. So we have here NLP not only after the named entity recognition. In fact, we can add any module anywhere in between tagger or before tagger, between parser and tagger, between NER and parser, or after the NER. All right. So let's go ahead and create first sententizer. So here we have NLP dot create pipe, and then here we have sententizer. All right. Then we are going to add this in a pipeline NLP dot add pipe. So in this we are gonna add sent, but we are going to add this sent before parsing. Otherwise, what will happen? If parsing is already done, then the token will become a single word. Then sententizer will not work in that case. That is why we have to put the sententizer before a parser. Let's go ahead now, get a doc. A doc is equal to NLP and there is a text. Now what we are going to do, we are going to print the sentence. All right, so for sent in doc dot sends. All right, so print sent. So in this case, now you see they have three sentences, so it has broken down those sentences into a whole document or whole text into three sentences, which you can also verify that these are the actually three sentences. So this is how the beautiful this SpaCy works. It works better and faster than the traditional NLTK. All right, so let's go ahead and see first stop words. For stop words, why stop words? Because we need stop words to reduce our data set and to also reduce the effects of most frequently or most repeating words. Like if you see here in these three sentences, is occurring most of the time, one has occurred 2 times, and this, okay, and these things are actually the stop words. So let's go ahead and see what are these stop words, how many stop words are there. So let's say SpaCy dot lang dot en dot stop words. All right, then from here import stop words. All right, so here we have stop, and we are gonna say stop words is equal to just list of all the stop words. Let's go ahead and print the stop words and see how many stop words are there. Now you see here, these are the stop words. So these are the most frequently repeated words in any the English literature. Like you see, beyond, hers, anyhow, seemed, for, although, therefore, beforehand, something. So these actually doesn't convey much information. That is why these words should be removed. Now let's go ahead and see the length of these words. So you see here 326 stop words are there at the time of this video I am making. If you are watching, of course, later the time when I am making this video, the count of stop words might change. Okay, it can get bigger or it can be reduced. It depends on the people who are managing the SpaCy library. Alright, so now let's go ahead and remove these stop words from this sentence and see how many actual words will be left out. Alright, and to do that, what we can do, we can say here for word in doc. Alright, so that is the token actually. Alright, so this is actually a token. For token in doc, if token dot is stop, I mean if token is stop word, equal to false. If token is not a stop word, then what I'm gonna do here, I'm gonna print that token. Oh, it says that all the words are actually stop words. Alright, so let's go ahead and make some changes to test it. I'm gonna add here just Apple, Google. Alright, so let's go ahead and run these things again. Now if you see here, we have this. Now here we are gonna get our sentence. Apple, this is first sentence, and Google, this is another one, and here third one. All right, so let's go ahead and run these things again. Here we have now still we are not getting anything. Let me see why we are not getting anything. Let me see if it is working. Oh, I think the spelling is wrong actually. Sorry, my mistake. All right, so we have here token. Now you see here the Apple, a sentence, Google, and this third. So these four the words, and along with these punctuations, we will remove these punctuations later. But you see the words, these four words are actually not in stop words. Otherwise, you see how many words were there. So this was a quite large word, and if we make a bag of word, which is mostly a sparse matrix, that becomes very large. But if we filter out the unnecessary words, the total bag of words size becomes less, which takes a less amount of the time to train your model, and also it increases the accuracy and it generalizes your overall model. Alright, so this was how you can remove a stop word. Now let's go ahead and see how you can do a lemmatization. For a lemmatization, let's say you have here a doc is equal to NLP, and there we have a runs running runner. All right, so let's go ahead and see. So let's say your text have something like this word. I mean, in your text, a text originated from same root, just having a different the different participle, like some words are in present participle and some are in a plural form and some are past participle. So in that case, what SpaCy do, SpaCy brings down, lemmatization actually brings down those the variations of words into a root form. So let's go ahead and run this. And then what we are going to do here, for lem, that is the lemmatization, for lem in doc, and then we are gonna just print those documents which we can print with lem dot text, actually that is the real text, and with a space I'm gonna say that lem dot lemma with a space, then it will print a real number. These words, all right, in a string format. So let's go ahead and run this. Now you see run is run, but runs is run, running is also run, runner is only run. Okay, that's mean these the 4 words has been converted into just 2 different words, run and runner. All right, so this is how lemmatization work. Now let's go ahead and see the part of speech. All right, so for part of speech, what I'm going to do here, let's say you have a dog. Okay, in a dog here I'm having NLP, and there I say all is well at your end. Okay, so here we have a dog. Now we are going to do a part of speech analysis on this lesson. So how we can do that? For token in doc, and then print token dot text, and then a token dot pos, that is the part of speech. All right, so run this. So it says that all is determinant, is auxiliary verb, well is adverb, and at is adpositions, your is pronoun, end is noun, and here is a punctuation. All right, so with this we can get a part of speech, and with the dependency parsing we can also understand the relation between these, although we'll understand this with the SpaCy graph later. Okay, all right, so now what I'm going to do here, I'm going to do entity detection. All right, but before that I'm going to display here dependency. All right, so using a SpaCy. So let's go ahead, work with the SpaCy dot render, and inside that I'm passing here a doc, and then here we have a style, and in the style we are matching a div. We run this. Now you see here, along with the part of speech, it is also showing that the dependency, how it is dependent. So it says that end is dependent on your, which says that okay, so it's a possessive. Okay, so like your end. All right, and then at end, you can get the complete the annotation details here. You see SpaCy.io API annotation part of speech tagging. So here is a complete list of the annotations. So this is how the tagging is being done. When we will be doing a Twitter sentiment analysis and the Facebook post sentiment analysis, then we will be talking about more about the part of speech and the dependency. All right, now let's go ahead and show you how you can do entity detection. All right, so I already have here a text, a very large text. Okay, so this is text from New York Post, which we have here currently, and you see here, you run and you can see the dog. So this is the kind of a news, okay, a small news, which says that New York City on Tuesday declared a public health emergency and ordered mandatory measles vaccinations amid an outbreak. All right, so this is the information, and now what I'm going to do, I'm going to do entity detection in this news. All right, using a SpaCy. How would you do that? Let's go ahead and do that. Use the SpaCy dot render. Actually, I already have this entity detection covered in my the previous video. You see here, expanding named entity recognitions, and I have also done that named entity recognition later in these videos as well. like in tutorial number 4. You can go ahead and watch these in details, but in short, I'm going to show you here. So here display.render, and then you have a doc, and with the style which you are going to get, that is the ENT, just run it. Now once you run it, you will get a fantastic and very beautiful named entity recognition. So it says that New York City is a geographical location, the Tuesday is a date, and at least 285 is a cardinal number, that is the number, September is a date, and Brooklyn is GPE, that is the geographical location, and then Williamsburg is also geographical location. Then here we have a 4 is cardinal, and then Bill de Blasio is a person name, that this person is a mayor actually, and then Tuesday is a date, Orthodox Jews is the NORP, I'm not sure what is the NORP, let me see, named entity NORP. NORP is nationalities or religious are the political groups, yes. All right, so and young is 6 months old, that is the date, and here is money. So this is how it's a beautiful look, and you can analyze. All right, so now what I'm going to do, I'm going to start our text classification finally. All right, so you have got the overall idea how we are going to work on this. So we'll be doing lemmatizations, and we'll be also doing stop words and the punctuations removal, the first of all. But first, let's go ahead and get and understand the data which we are going to use. So I already have this data set, and I have downloaded this data set from the Kaggle and UCI machine learning the data set. But I'll upload these data set on my the GitHub. You can get the link from a video description. So I'll post the link for this Jupyter notebook as well as for this data. You can get these things from there itself. Okay, you don't need to download it from anywhere else. So you see here, I have here a 3 file, Amazon sales labeled. Now if I open this, you see, so this is kind of, there is review and there is a sentiment. So there is no way for me to plug it in here in the US unless I go for a converter. That means this is the negative review, so it's 0. Good case, excellent value, that is the 1, that is the positive review. Great for the job on, positive review. But you see here, needless to say, I wasted my money. This is the negative review. So here we have Amazon, and similarly we have here for IMDB 01001, and this says that this is the tab separated file. Okay, and then here we have Yelp labeled files. All right, so these are the 3 files which we will be reading. I mean the data we will be reading from these 3 files, and then finally we will be combining these 3 files together for final analysis. All right, so let's go ahead. First, import necessary libraries which we will be needing, and those necessary libraries are import pandas hpd. All right, and then we will be also needing sklearn, lots of libraries from sklearn, like a feature extraction dot text. If you have seen my first video, in that video I have explained this TF-ID vectorizer. So here we have TF-IDF vectorizer, and then from sklearn, then we have here from sklearn dot the pipeline, import pipeline. All right, then here we have from the sklearn dot model selection, import train test split, and then here we have the from sklearn dot metrics, import accuracy score, classification report, and then confusion matrix. Now you see here we have a confusion matrix, classification report, and accuracy score. So these are the 5 libraries which we will be needing during our text classification. So as I have shown you these 3 data sets, so let's go ahead and read all these 3 data sets and do some exploratory analysis. So I'm going to first read Yelp data. So I can just say the data underscore Yelp, is equal to pd dot read underscore csv, and then give file name, it is under datasets, and elf labeled .txt. And I need to also define here a separator which I'm going to use. The separator I'm going to use a tab separator. This is not CSV file. And for header I'm going to assign none header. All right, otherwise the first row becomes a header. So after this I'm gonna see the first few lines with the header command. These are the first few lines you see here. This is the review and this is the sentiment. All right, so what I'm going to do here, I'm going to create a column names first. Columns name is equal to, so here we have a first review and then another one we have a sentiment. All right, and we are going to assign that to data elf using data elf columns is equal to column names. All right, now you see the data elf dot head, you should get that review and sentiment in the header of this pandas data frame. All right, so let's go ahead and see a shape of this data elf. How would you get that? Data elf dot shape. So it says that it has 1000 reviews and 2 columns. The first column is review and the second column is the sentiment of that review. And now we are going to read the data set from the Amazon as well. So the data underscore Amazon is equal to pd dot read underscore csv and the data sets, and then here we have Amazon sales labeled .txt. Then here we have a separator which I'm gonna use, that is t. All right, and then finally all right, so I'm now gonna use data underscore Amazon dot columns. All right, is equal to columns name. So let's go ahead and see the first 5 lines of data Amazon. All right, so here we have the data from Amazon, and if we see a shape, it says that it has a total 999 reviews only. All right, and I think we have missed here we have missed actually the header, so we should put here the header is equal to none. All right, so now we should get total 1000. All right, great. Now similarly we are going to read the data from the IMDB. So we have read from Amazon sales elf labeled, and let's go ahead and read the for IMDB labeled .txt. And for that data underscore IMDB is equal to pd dot read underscore csv, and then here we have data sets, then here we have IMDB label.txt, and similarly here we should set separator with tab separator and header should be none. All right, so we have data.imdb. Now data imdb dot columns is equal to column name. All right, so with this we have data.imdb dot columns is equal to the column name. The column has been assigned. Now let's go ahead and see the shape of this data. It says that it has total 748 data. Let's go ahead and see a few lines. First few lines of this data, it says that okay, these are the review and these are the sentiments. All right, so we have total our 3 type of data: data elf, data IMDB, and data Amazon. Now what we need to do, now we need to mix all the data together. So let's go ahead and append all the data together in a single data format, single the pandas data frame data. So the first of all I'm gonna call data elf dot append, and inside that I'm gonna append first data dot Amazon, and then I'm gonna append data.imdb, and then I'm gonna say that ignore indexes is equal to true. All right, so now you see the data shape should be more than 2000. Yes, so the data shape is 2748 and there are 2 columns. So with this we have got our the new data, that is the data shape. Let's go ahead and get the head of this data. So it says that okay, this is the head. Now you see we had first a data elf, and now if we go and see data elf, you see those first 5 lines are from data elf, and then the data Amazon is appended, and then finally data IMDB is appended in a data format. All right, so let's go ahead and check what is the distribution of the sentiment. That we can check with the data sentiment dot value underscore counts. All right, so it says that we have total 1386 positive reviews and 1362 negative reviews. All right, and then we have, now what we are going to see here, we are going to check if there is any null value. Okay, so it is data dot is null, and then here we have a sum. So it says that there are no null values present in the data set. All right, perfect. So let's go ahead and add a few the empty cell here, and then I'm gonna do here a tokenization. All right, so here we have a tokenization. All right, so now the data is ready. Earlier I told you that we will be first doing a tokenization, then we will be removing stop words and then punctuations, and then we will be doing lemmatizations, and then we will be converting all the text into a lower the format. So let's go ahead and first do the tokenization. For tokenization, I'm gonna first import a string, and from that I need to get a punctuation. All right, so here we have punct is equal to string dot punctuations. All right, this is the punctuation. Sorry, this is actually the punctuation. All right, so let's go ahead and get this. This should be the punct. All right, now you see here this is the punctuation. All right, perfect. Now what I'm going to do, I'm going to write a function for a data cleaning. So how the data cleaning will work? The data cleaning will first convert, will check if word presents into a stop word, as we have done earlier in this lesson, and also if it is not a stop word, and if it is not a punctuation, and if it is not a pronoun, that's mean like a name, etc., then that will be converted into a lower format. So what I'm going to do in a lower text, I'm going to write here the first that function by calling def text underscore data underscore cleaning, and this is going to take a sentence. All right, oh sorry, I need to first write something here, only then I can run it. Okay, so the first we are gonna get here doc. Doc is equal to NLP, and then here a sentence. All right, so doc NLP sentence. Then after that I'll be making here a list of token. Okay, then I'm gonna do here lemmatization first. Okay, so here let's go ahead and make it actually the tokens for token in doc, and then inside that if token dot lemma underscore, do you remember this dot lemma? So this is the lemmatization, I mean the root form of that word. If root form of that word is not a pronoun, all right, if root form of that word is not a pronoun, then it is going to convert that into a lower format. So here we have a temp is equal to token dot lemma dot lower. It will convert into a lower text format, and then if there is any extra characters, punctuations, then it's gonna strip that. Okay, and if it is a proper noun, then else I'm gonna just get that lower format of that proper noun. All right, so there is no lemma for a proper noun. So the temp is equal to token dot lower underscore. All right, so with this we will get here lower. All right, so now token, so actually the tokens here, this is the tokens, so every time I'm gonna append the token, and that is the temp. All right, so append temp. So with this we have got here, we have converted, we have lemmatized and converted the text into a lower format. All right, now after this what I'm going to do, I am going to clean the tokens. Okay, so I'm gonna get cleaned, I'm just gonna write here cleaned underscore tokens is equal to for token in tokens. Now I have tokens. Now I'm going to look inside the tokens and then checking if there is stop word or punctuations, then remove those. So if token not in stop words, do you remember stop words? There were more than 300 stop words. And token not in punctuation. All right, that is the punct. Okay, so if it is not in stop words and the punctuations only, then add that token in a cleaned tokens. So that is the clean token dot append, and then there is a token. All right, so then finally what I'm going to do here, return this cleaned tokens. Let's go ahead and run this. Now you see here, this is a complete function. So for testing purpose, what I'm going to do here, I'm going to call this function text data cleaning. All right, so here I'm going to say hello, how do you like this video. All right, so I'm going to run this. Now once I run this, you will see here hello, like, and the video. All right, so how are you, these are the very common words, that is why it is removed. And this is also very common word, it is presents into a stop word, and this punctuation you see has been removed. Now if you see here I add spaces, that spaces will be also removed. Only these necessary the words or the tokens will be returned from this text data cleaning. All right, so in this line we have done lemmatization, and in this line we have removed stop words and the punctuations. All right, now we are going to do vectorized feature engineering, that is the TF-IDF. This is the vectorization feature engineering, TF-IDF. All right, so for TF-IDF I'm going to use here the SVM. So it is the from scalar dot svm import linear svc. All right, and I am also going to, do you remember that I have imported the TF-IDF in the initial of this lesson? That should be somewhere. Let me see, where is that? Do you remember that? Where is it? I think here. Yes, so here it is the TF-IDF and the pipeline. So now we need all these libraries, all these the packages. Actually those packages were needed to import from here itself. All right, so I'm gonna first create here TF-IDF. TF-IDF is equal to TF-IDF vectorizer. Now if you press shift and the double tab, you will see here lots of the input it takes, like lowercase is the true preprocessors, tokenizers, and the analyzer. So inside this tokenizer, I'm gonna pass this function name, okay, the text data cleaning. All right. So it has tokenizer is equal to this text data cleaning. So the tokenization will be done according to this function. All right. That means this sklearn package is gonna use a function written with the help of the SpaCy functionalities. All right. So we need to just write this line, and then here I am gonna say a classifier which we are going to use. The classifier is our linear SVC. All right, perfect. So let's go ahead and get first X data. Do you remember that inside the data we have two columns, a revive, and Y is data sentiment. So these are the two X and the Y data. Now what we need to do, we need to perform train and the test split. X underscore train, X underscore test, Y underscore train, and then Y underscore test is equal to train test split. Now inside this I'm gonna pass here X, Y, and then test underscore size is equal to 0.2 and random state, so that you should get the same result. Random state, which is this, random state is equal to 42, let's say. All right, so here we have got X train, X test, Y train, and Y test. Now do you remember I had created a pipeline in the first lesson here in this lesson? The pipeline help us to perform the operations at the same time for training and the testing data as well. We don't need to prepare the data for training and the testing separately. So what I'm going to do first, I'm going to check the shape of the training data set as well as the shape of test data set. And it says that 2198 data samples are in training data set. And if you see here, X train is just a words, okay? Now with this vectorizer, okay, the TF-IDF vectorizer, when we pass the data in TF-IDF, it will be converted, the whole X train will be converted into a bag of words. All right, perfect. So this is the X train. Now what I'm going to do here, I'm going to create a classifier that is the CLF dot pipeline, and inside this pipeline I'm going to create a list of tuples actually. So the first function or a first operation which I'm gonna perform, that is the vectorizer. So that is the TF-IDF. So the function of this TF-IDF is TF-IDF itself. Here I had created that TF-IDF. So this is the one tuple, and after this tuple I'm gonna perform the classification operation. So that is the CLF operation, and in that I'm gonna use a classifier. So how it works? So it will first do a vectorization, and then it will do a classification. All right. So let's go ahead and run this CLF. We have got the CLF. Then finally we need to do CLF dot fit, and then here we need to do X underscore train and then Y underscore train. So in this way we actually don't need to prepare the data set for X test as well. So we can directly do the CLF dot predict X underscore test. So this is quite a large data set, so it might take a little time since my computer do not have any GPU. But let it complete first, wait for a few seconds. All right, so this is completed. Now you see here, so these are the default function which we have used, all right, in the TF-IDF, the vectorizer and linear SVC as well. So in TF-IDF vectorizer, you see here we have analyzer word, and if you remember our we don't have stopwords here because we already did that defined in tokenizer. So here in tokenizer it has this function, data cleaning function. All right. and the C is 1.0. All right, so here we have our clf.fit is happened. Now let's go ahead and get the y pred. So here we get y pred, y underscore pred is equal to clf dot the predict, and I'm gonna operate that directly into x underscore test. Now let's go ahead and print the classification report. So there we have classification underscore report. In that we need to pass y underscore test and then y underscore pred. So it says that we have 78% of the accuracy. All right, so let's go ahead and print the confusion matrix as well. For confusion matrix we have y underscore test and then y underscore pred. So it says that here this is the confusion matrix. So this is the y-axis is actual and this x-axis is predicted value. All right, so this says that okay, the 0 sentiments, that's negative sentiments, and this is the positive sentiment. All right, so 0 and the 1. Perfect. Now let's go ahead and test it into a real world and how it is performing. So let's say if I say clf dot predict, and inside that I say wow, this is amazing lesson. So it says that here 1. All right, that means this is a positive sentiment. Wow. If I say wow, this sucks, then it says that 0. Now you see here wow is here and here as well, but what is making difference? This sucks is making difference. So this is the 0, that means here is negative sentiment. Now let's say if I say clf dot predict, and here I see worth of watching it, please like it. So it says that 1, that means this is a positive sentiments. Okay, all right, so this is all about in this lesson. Thank you so much for watching this video. Please do not forget to like and to subscribe this channel so that you can get updates directly into your inbox. Bye bye, have a nice day.